So we're going to continue in section 12.2, dealing with additional congruence theorems and talking about different ways to show triangles are congruent. So at this point, we've talked about side, 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 we've talked about side, angle, side, and even hypotenuse, leg theorems that show that triangles are congruent. And so we're going to jump right in and talk about side, angle, side. So we abbreviate that ASA, side, angle, side, angle. And what it says is that if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Now, if we had talked about construction, and we didn't really talk about construction in section 1 just because I'm not there with you physically, and it's kind of hard to explain how to construct angles and segments and triangles and stuff with a compass without actually showing you how to do it. And so that's not one of our main things for this class, so we end up skipping that. Had we talked about that, though, then we would see that if you were to take the measure of angle A in this triangle and you were to construct it, you would get this angle A prime. And if you were to take the measure of angle C and you were to construct it, again using a compass and all of that, then you would get angle C prime. And then if you know that the length of AC is a specific length, then A prime and C prime, that length should be the same. And based off this construction, if you were to extend this side out of your angle and this side out of your angle, then you would see that they intersect at this point B prime, which is the same as point B. It's going to give us the same angle measurement. Those side lengths would be the same, and so you would have congruent triangles. And again, we didn't do the construction. That's not a major thing, but I wanted you to see kind of how that would work, just to kind of help convince you of the fact that we do have an angle side angle property. Now, we also have what we call an angle angle side property, and that's different than angle side angle. Okay, so at this point we have side side side, we have side angle side, we have angle side angle, and now there's an angle angle side. Now, it's important to understand that the order of these letters does matter. So angle angle side is different from angle side angle. In angle side angle, the S, the side, is the included side between the two angles. In angle angle side, that side length is not included between the two. Okay, so what it says here for angle angle side, you can see the definition on the screen. If two angles and the side opposite one of the two angles of these two triangles, then that corresponds with the same parts in another triangle, then the two triangles are congruent. Now, look at this diagram. You'll notice here that angle B and angle E are congruent, and angle A and angle D are congruent. But then you have side AB that is congruent to side EF. Well, in this first triangle, this side length is between the two angles. That would be an example of angle side angle. In the second triangle, we have angle angle side. That is not enough to guarantee that these two triangles are congruent. And so you have to understand what's the difference in those, because again, the letter of those orders matter. Just like when we talked about side angle side in our previous videos, the angle between the two sides, the included angle as we called it, is different than being at some other angle randomly. Okay, we don't have an angle side side. Number one, that abbreviation would be inappropriate to have angle side side. But that also doesn't guarantee a congruence either. And so because of that, we have these four, and again, angle side angle and angle side are two completely different things. Okay, so just be aware of that. Don't just assume that, well, there's two angles in a side, so they're congruent. You have to make sure it's either the included side in both triangles or the opposite side in both triangles. So we're going to show in this example that these two triangles are congruent, and it doesn't tell us how. Okay, so it doesn't say use side or angle side angle or side or whatever. So there's a couple different ways that you can show these two triangles are congruent. The easiest is to use what's given to you. Okay, so when we look at these two triangles, the first thing that we notice, I hope, is that angle ABD, which is this angle, it is congruent to angle CBD, which is this angle. Okay. We also can see that they share a side, right? BD is a side they both have. And so we could also say that segment BD is congruent to segment BD. And again, angle B in both of these correspond together because they're the same, and so that would end up being the order of those letters is BD for both of those. And then we also see, it's given to us, that angle ADB is congruent to angle CDB. Now, based on that, we know that these two triangles are congruent. So we're going to say triangle ABD is congruent to triangle CBD by which property? Well, in this case, it is the angle side angle property, because we have an angle, we have its included side, and then we have the next angle. And so that is angle side angle. Now, what if you said, well, I wanted to show by angle side? Well, you technically could do that too. Because you know that a triangle has a sum of 180 degrees for its angle measurements, then you could take the 70 plus 50, which is 120, and subtract that and find out that this angle measurement of angle A is 60 degrees. And if you did the same thing with the other triangle, you would see that angle C is also 60 degrees. And so you could show that angle A and one of the other two angles that's given, either that angle B or angle D, are congruent. And then again, they share a side. And so you could actually show this by angle side, but you would have to use other measures than what we used. So if you use the three that we used, the angle of 70 degrees, the angle of 50 degrees, and its included side, the one they share, then that has to be done by angle side angle. And so you can see that's the way we did it. We said angle ABD and angle CBD are congruent. BD is congruent to BD, and then ADB and CDB are also congruent. Again, if you have any questions about showing that congruency, please let me know. Now, what about this one? So, this one is a little bit different, and we've got to kind of think about what do we know. So we've got this triangle that's in red, kind of towards the right. You can see that one. And then we've got the one that's in black. And it really only part of it's in black because it's overlapping with what's in red. So what do we know? Let's just take this triangle ABC. So So that's this one. So let's start with it and let's think about what do we know. Well, we know the measure of angle A is 30 degrees. We know this angle of measure B is 90 degrees. And we could find angle C if we needed to. It's 60 degrees, we could find that, but not necessarily something we have to do. And then what do we know from a side length standpoint? Well, we don't know the length of AB. We don't know the length of AC, but we do know this length of BC. We know that one is 3 units. So we can approach this from a pretty easy standpoint where we talk about this 30 degree angle, this 90 degree angle, and then this side length of 3, which would give us angle, angle, side. Or we could try to find this angle measurement down here at the bottom for angle C and try to use that. It's easiest to use what you're given. So what I'm going to do is I'm going to look at this and say, well, angle A, and we only have to use one letter because there's only one triangle and one angle at that point. Angle A is congruent to angle D. We know that, right? They're both 30 degrees. We also know that angle ABC, that's the 90 degree angle, is congruent to angle DEC. That is also the right angle. So we know 2 angles. We don't know their included side though, because the included side would be this one. And we don't know it. But we do know the other side length. We know BC is 3 units, and we know that it's congruent to EC. That's also 3 units. So, based on all that, triangle ABC is congruent to triangle DEC. Again, make sure you have all your letters in the right order. And we know this by angle, angle, side. Again, we didn't have the included side, we had another side, and so it is congruent by angle, angle, side. And so again, that's what you see here. But notice that angle C got used because they share that. Right? Now it's 60 degrees, but we don't really have to know that because we know that they share that. And so what was used here by the book, and again, I'm taking some of this from the book, they used the 30 degree angle, they used this angle they had included, and then, or that they also had together, and then this length. Well, we used the 90 degree angle instead of angle C. Either way works. It is perfectly fine as long as you're showing that one angle, another angle, and then a side, if you're using angle, angle, side, a side not between those. And so that's what got used here. It's not a big deal to do it that way or the way that we did it. Now, look at this one. This one is a little more to it, a little more in depth. We're kind of starting to get into some proof things here. Showing that 2 triangles are congruent is a type of proof, but it is not quite the type that we're going to get into here with this problem and then some following this. So, look at our statement here. It says, using the definition of a parallelogram. Now, we got to go back and think about, okay, what do we know about parallelograms? Well, we know that in a parallelogram, so let me just draw a sketch here. We know that this side and this side are parallel, and this side are parallel. Okay, that's one thing we know. So, and really that's the main thing we need to know at this moment. It says using the definition of a parallelogram, and the property that opposite sides in a parallelogram are congruent, meaning that this length and this length are the same, and this length and this length are the same. We want to prove that the diagonals of the parallelogram bisect each other. We talk about the word bisect, it means they split each other in half. Okay? So what we're trying to show is that this length and this length are going to be the same, and that also this length and this length are going to be the same. Okay, now, one thing that we also know is that if this is a parallelogram, then this segment that you see, BD, is considered a transversal. And so it's a parallel line cut by a transversal, which means that this angle B, CBD, has to be congruent to this angle D, ADB, because they're alternate interior. And the same thing is true going with the other diagonal, that this angle BCA, so that's this one, and the angle DAC, which is this angle, they have to also be congruent because they're alternate interior angles. Okay? So, based on all of that, we are trying to show that this side length and this side length are congruent, and then this side and this side are congruent. So, what do we know? Well, again, based on the property that's given to us in our definition. So let's just make a list of some things we know. We know that side BC is congruent to side AD. Probably should say DA actually, because let's do that. So, excuse me, side BC and side DA are going to be congruent. We know that. And again, that's given to us because opposite sides are congruent. We also know, because opposite sides of parallelogram are congruent, that side AB is congruent to side CD. Okay. So again, this side and this side are congruent. We know that angle BCA, so BCA is congruent to angle D, so angle DAC, because they're alternate interior. We also know that angle CBD is congruent to angle ADB, because again they are alternate interior. And so we can kind of stop at this point and say, okay, do we know enough to show that, because what we're trying to show is that AO, that segment, is congruent to CO. And we're also trying to show that BO is congruent to DO. This is what our goal is. We're trying to show that this is true. So do we have enough information to do that? Well, if I can show that this triangle at the top is congruent to this triangle at the bottom, well, then I can show that AO and CO are the same. And I could also show that DO and BO are the same. So do we have enough to show that those two triangles are congruent? Well, yeah, we do. Because we know that AD and BC are congruent. So we know that. That's this angle, or this side. And then we also know that these two angles are congruent, and these two angles are congruent. So what we know is we know an angle, we know a side, and we know an angle, and we know that they're corresponding with this angle, this side, and that angle. So based on the angle, side, angle, so angle, side, angle, we know that triangle AOD has to be congruent to triangle, make sure I get all the letters in the right order here, COB. And based on the fact that corresponding parts of congruent triangles are congruent, BO must be congruent to DO. And again, you can see the order of the letters being in the right place. So DO would be there and BO would be there. And that also tells me that AO must be congruent to CO. And again, you can see AO and CO there. Now, I've kind of walked through that. Hopefully, didn't lose you there, but I've got some stuff on the screen that we're going to kind of walk through, very similar to what we did. So we identified, first of all, what are we trying to show? And we saw that, we talked about it, we didn't write it down maybe as our first thing, probably should have, but we ended up writing it down over here. Over here to the left, you can see where we wrote that down. So that's the first thing. Okay, now, based off of that, since we're trying to show that, we really just needed to show those two triangles had to be congruent. And so we started listing the things that we knew. So, we knew that segment AD, so this one at the bottom here, and segment CB, we knew those had to be congruent based off the fact that it told us in the problem that opposite sides of a parallelogram are congruent. And so since they were AD and BC were parallel, then we could find those alternate interior angles, which we did. And so again, based off of that, angle, side, angle allowed us to show that those two segments we were trying to find were congruent. If you have questions about that, again, this is our first real proof that we've talked about. And I will say that it's important to make sure in a proof that you understand what are you looking for. Once you identify what you're looking for, then figure out, okay, what do I need to be able to show that is true? And then if I can show that's true, then how do I go from